responding. I believe you just ended your break now. Alright, quickly we'll be looking at the proof for this assignment I gave you last week. I know some of you might have tried, you have spent time doing this. So let's quickly look at it. How to prove by mathematical induction that this will result to this. Of course, by now, everyone should know that this is a series. And why is it called a series? Because we sum each term together. Without the addition sign, it will be called what? It will be called what? Yeah, it will be called a sequence without the addition sign. So as it is now, it is called a series. So how are we going to show that the sum of this will result to this? So that's what we are going to be doing using math induction solution. So we have 3 steps in math induction. I believe you can remember that. The first step is to do what? To show that it is true for S of 1. Is that correct?
Yes, sir.
Where our S of n is that formula n into n plus 1 over 2. Sorry for the board. So this is our S of n. Like I explained earlier on, that this is a function of what? N. A function of n, right? So that means S of 1 is to replace n with 1. And we are going to be doing that. We call this one the left hand side and call this one the what? The right hand side. So we show that it is true for S of 1. Then we now assume truth for what? S of k for both the left hand side and right hand side. Then the third step is to show that it is true for S of k plus 1 for both the left hand side and the right hand side. So let's start with the step 1. Step 1. Step 1 is to verify. Verify for S of 1. So to verify for S of 1, that simply means that n is what here?
1.
N is what?
1.
N is 1. And if we want to consider the left hand side, if n is 1, how many terms do we have here? How many terms are we going to take here? How many terms are we going to pick here?
1.
1. Since n is 1, just pick one term here. So if n is 1, for the left hand side, we have what? 1 raised to the power of what? 3. Is that correct?
Yes.
So 1 raised to the power of 3 is what?
1.
You are laughing. My marker wanted to 4. I don't know why. Okay. So 1 cubed is what? Is 1. That's for the left hand side. You can see we picked only the first term because n is what? 1. So for the right hand side, what am I going to do? Right hand side, I'm going to replace n with what? With 1. And that will give me 1 into 1 plus 1 over 2. Everything squared. So let's see if we are going to get 1. So what is 1 plus 1? 2. 2 times 1? 2 divided by 2?
1.
So we have 2 divided by 2, or 1 times 2 by 2, all squared. So that's 1 squared, and that will give us what? 1. So we can see that the left hand side is the same thing as the what? The right hand side. So we can conclude here that this particular formula is true. It is true for S of 1. Or you write when n equal to what? 1. Are we good?
Yes.
Are we good?
Yes.
So step 2 now. Step 2 is just an assumption. We are going to assume that it is true for what? Assume that it is true for what? It is true for what?
S of k.
Eh?
S of
So
k.
for S of k, very good. Okay, someone should get me a duster. God save. Thank you. So we want to assume that it is true for what? For S of k. This simply means that our n is now what? N is now what?
K.
So this is just an assumption, so we don't have any problem with this. We are going to write this in terms of k now, and it will be written as 1 cube plus 2 cube plus 3 cube plus dot 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 plus k to the power of 3 equal to k into k plus 1 over 2 all squared. So we can call this equation 1. So what did I do? I simply replaced n in the question with what? With k. So it can be any other letter if you like. So but we are using what? K. So this one is an assumption. We don't have any work to do here. So we move to step 3. Step 3. And what is the step 3? Anybody? You know it, raise your hand. Step 3. Okay. Alright, Ine will tell us what's step 3. What's step 3? Eh? Okay, David, help me out. Speak up.
You replace n with k plus 1.
Very good. So for step 3, we are going to verify for s of k plus what? 1. So, and it's still correct. He said we are going to replace n with what? K plus 1. So it's the same thing. So we are going to verify that it is true for what? S of k plus 1. That's by simply replacing n with k plus what? 1. So if we do that here now, we'll have 1q plus 2q plus 3q plus dot 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 plus k plus 1q. Instead of n, I'll write k plus 1q. Equal to, then for the right hand side, instead of n, I'll write k plus 1. Then instead of n, I'll write k plus 1 plus 1. Everything over 2 all squared. So I have successfully replaced n with what? K plus 1. So but the challenge here is that I must show that the left hand side will still give me the same answer as the what? Right hand side. The left hand side must give me the same answer as the what? Right hand side. So how will I do that? Considering the fact that I have dot dot dot, these ellipses, I can't add them up. So what will I do? I will expand this sequence. I will do what?
Expand this sequence.
So that this sequence can contain this sequence here. Expand this so that we contain this. So what do I mean by that? We know that it is a series. It is succeeding from one level to another. Just like we have 1 cube here, we have 2 cube, we have 3 cube. That means we can have 4 cube, 5 cube, and so on and so forth. So before I will get to k plus 1, that means I should have k cube. Is that good?
Yes, sir.
Are we good?
Yes, sir.
Are we good?
Yes, sir.
So I can write this sequence as 1 cube plus 2 cube plus 3 cube plus dot 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 plus, now before this I will have what? K cube plus what? K plus 1 cube. That's for the left hand side. That means right hand side, if I simplify this, I will have k plus 1. K plus 1 plus 1.
K plus
So I'll write k plus 2 here over 2, everything all squared. So this is what I will do. Now, how will I simplify this to get this? Someone else can decide to expand this, which is so stressful. Why someone else will decide to work from left hand side, maybe simplify this to get this. Of course, that's what I'm going to do. I'm going to simplify this to get this. And since I have this now, I can replace from this point to this point with what I have in my step 2. Because from here to here is same as from here to here. So instead of using all these ones that contains dot dot dot, I will use this formula here. So I can call this equation 2 and say put 1 in where? In 2. Are we good?
Yes, sir.
Any questions so far?
No, sir.
Any questions so far?
No.
Victories, are you here?
Yes.
Any question? Emmanuel, any question? Okay, moving on. So I'm going to replace this with what I have there. So if I replace it, I will have k into k plus 1 over 2 all squared. That's this guy here. Plus, I will need to write this to k plus 1 cube. Is that correct? Over 1. So I will leave this one like this. I will leave this one like this. Who is distracting us? Who is distracting us? Stop distracting us. Stop distracting us. Okay, alright. Are we together? Are we together?
Yes, sir.
Hello?
Hi.
Are we still together?
Yes, sir.
Any confusion?
Yes, sir.
Okay, so I'm going to simplify this. This squared is going to come in. So if this squared is to come in, the square will come on this, will come on this, will come on this. So that will be k squared, k plus 1 squared over 2 squared, which is 4, plus k plus 1 cube over 1. Any problem with this?
No, sir.
Is there any magic here?
No, sir.
Charles, is there any magic here? So, I said square here will come inside. We come on this, come on this, come on this. It's just like if you have 3 times 2 over 5 all squared. So it simply means 3 squared times 2 squared times over 5 squared. Do you understand? So it's the same thing we did here. Alright. So if we find the LCM, you should have at the back of your mind that what we want to achieve is to make this look like this. So if we find the LCM of course is what? 4. The LCM of 4 and 1 is 4. So 4 divided by 4 is what? 1 times this is what? So if you see give us the same thing, k plus 1 all squared. Plus 4 divided by 1. 4 divided by 1. 4 times this. 4k plus 1 all cubed. Is that correct?
Yes, sir.
Now, you can see that we have 2 terms here.
Yes, sir.
This is the first term plus the second term. So you can see that k plus 1 squared is inside this k plus 1 cube. It's just like you have 2 squared plus 2 raised to the power 5. So you can see that you can write this as 2 squared plus 2 raised to the power 2 times 2 raised to the power 3. So that means 2 squared is inside here. Are we good?
Yes, sir.
So that means I can factor out this k plus 1 squared. If I factor out this k plus 1 squared, I will obtain this. This one is out. So inside the bracket, I will be left with k squared plus what? 4 into k plus 1 because I factored 2 out of this thing out. So I will close this. Everything over what? 4. Any confusion?
No, sir.
Any confusion?
No.
Yet, it is not still looking like this. So I will have to simplify further. I will have to simplify further. So this will give me k plus 1 all squared. Then we have k squared plus, expanding this now, 4 times k will give us what? 4 times k,
4K.
4 times 1,
4.
so over what? 4. So of course, from what you have learned in quadratic equation so far, you will know that this is a perfect square. But let's say you don't know what we mean by perfect square. Let's factorize this. That's quadratic factorization. Are you here?
Yes, sir.
So if we have to factorize this, that's k plus 1 all squared. The 2 factors are what? 2k plus 2k plus 4 over 4. That is because 2k times 2k will give us this 4k squared. And 2k plus 2k will give us 4k. So simplifying, we have k plus 1 squared. So this will give us k. K is common between these two. Then you have k plus what? 2. Then plus 2, k plus 2. Everything over 4. So we can use bracket here. Now you can see that k plus 2 is common. So I can factor out that k plus 1 squared, k plus 2, and k plus 2. Everything over 4. So is it looking like this?
No.
Not yet. So we can still call this k plus 1 all squared, then k plus 2 all, because it appeared 2 times. So you can say k plus 2 all squared. That's why it is called perfect square. Like you have 2 squared, 3 squared, they are all perfect square. Everything over 4. Is it still looking like this? Not yet. So we can still write this as k plus 1, k plus 2. This squared is common here, so I can write it outside and write this over 2 squared and write this as squared like this. Any problem with this?
No.
Any problem with this? So you can see the squared is now common for both numerator and denominator. So I can write this as k plus 1, k plus 2, everything over 2, all squared. Finally, it is now looking like the right hand side. So we can say that this is equal to the right hand side. So the conclusion is very important. So we can now conclude that it is true for s of k plus 1. This implies, therefore, it is true for all positive integers. Please manage the board, because that is the solution to that question. Any question?
No, sir.